In my presentation today, I will review a recent application note on the high throughput analysis of geochemical samples with the Avio 560 Max ICP-OES. So with geochemical samples would include rocks, soil, sediments, plants, anything used for geochemical means to assess a mineral deposit or for exploration purposes can be tested. We're looking at the elemental composition of these materials, again, for the exploration, development of mineral services, and potentially to understand what could potentially leach out of these materials for environmental protection reasons. For the analysis of these samples, ICP-OES is a very commonly used instrument. It's highly tolerant to matrices, it has fast sample-to-sample time, it can simultaneously measure many elements, and it can measure over a wide concentration range. The PerkinElmer Avio Max series comprises of the hybrid simultaneous ICP-OES, the Avio 220 Max, and then the fully simultaneous ICPs, the Avio 550 and 560 Max models. The Avio 550 and 560 models differ in the built-in HTS unit in the Avio 560 Max, which I'll talk about today. The highlights of the three different models of the Avio Max series are shown here. All have the common benefits of low argon consumption, smart software, PlasmaShear, and a nice small footprint for the laboratory. So, what is an example of a high throughput laboratory? Well, the primary example today is going to be geochemical labs, which can easily get in hundreds, if not thousands of samples at a time. And then they need to digest the samples, prepare the samples, analyze the samples, and then get the results out within very short turnaround times. They will likely run multiple shifts a day just to keep preparing and feeding the instruments. Another example can be environmental testing laboratories. They're very similar in that they require to process hundreds of samples per day and likely can have multiple shifts in order to accomplish that. Other laboratories, a similar need for higher throughput or fast turnaround are quality assurance, quality control, production, some food labs, pharmaceutical labs. All these sorts of labs need to monitor the quality of a product or a process, and they don't want the instrumental analysis to be a bottleneck in their release of those products throughout the day. So they want the instrument to run as fast as possible so they get the results out and the product out to market as fast as possible. Some commonalities of these labs is that the analysis is typically routine. The methods are developed, the methods are fixed. So analysis is routine. We just need higher throughput. And so profit is tied to this throughput, and getting the results out faster means more profitability for the laboratory. So if we look at laboratory challenges, and we look at a lot of the challenges of a modern lab is reducing operating costs, having easier to use software, having, as I said, faster turnaround time, and less bench space. So operating costs, the big cost of running an ICP is typically argon gas. And this is where the Avio series really shines, by using the least amount of argon gas of any ICP on the market. Also software, making it easier to use, especially for these routine analyses, is very important in a high throughput laboratory. Quick start, quick analysis features of the Avio software make things faster, make things easier. Then turnaround time. Having faster sample-to-sample time is very important, especially, as I said, in these high throughput laboratories and laboratories that need quick turnaround on the results. And as many of you know, space in laboratories is coming to a premium. More and more we're being evaluated on how much space or bench width does an instrument take. So ensuring that the Avio 560 Max takes up the appropriate bench space is definitely considered in design. So a couple of features that are common to the Avio Max series are flat plate technology. This is a unique technology of PerkinElmer that allows the laboratory to save on argon gas. Typical plasma cooling gas flows are in the range of 8 to 10 liters per minute, where you see competitive systems typically around 15 liters per minute. Next is PlasmaShear technology. The fewer the interferences, the better, right? We all know that. And the PlasmaShear removes the cool part of the plasma, allowing for better viewing of axial emissions. This technology eliminates the need to use cones that require maintenance and run completely on air, so no additional argon is needed, like in other ICP designs on the market. Then, vertical dual view technology. This allows you to extend your working range by viewing high concentrations like major cations like sodium, potassium, magnesium, calcium. You view that in the radial view of the plasma. Whereas when you're looking at your trace elements, they can be viewed axially down the axis of the plasma, which has greater light emission due to the longer path length. The combination of these two views in dual view technology provides the ultimate flexibility for the laboratory. So the Avio 560 Max ICP-OES was built with productivity in mind, built with the high throughput sampling incorporated into the spectrometer. We've developed software to help simplify method development with predefined methods and auto background correction in the software. And ease of use. We have an express analysis option in the software that allows the user to easily run routine analysis. Complete productivity offerings also need to discuss autosamplers. So with the PerkinElmer 560 Max ICP-OES, in addition to high throughput sampling, next generation autosamplers are also available with a 3-rack design or a 5-rack design. They have dual rinse stations and are very excellent and reliable, precise XYZ type autosamplers. So here you can see the S23 next to the Avio 560. And this is a picture of the instrument actually in one of our technical centers, just to give you an idea of how small the footprint is. It can come on a rolling bench, which we recommend for ease of service and maintenance on the systems. You'll note that the exhaust is connected to the top of the instrument. It's designed to reduce the air consumption for the ICP, which is ultimately drawn from the laboratory, and this helps maintain the climate control in your lab. So yeah, here's a look at the instrument, how it would look in your lab. So if you notice on the previous slide, down where the pump normally is in the Avio or on other ICP systems, is in this case the PerkinElmer High Throughput System. This is a one-piece pump, valve, and vacuum pump all in one module. Makes for ease of installation or upgrading. If you went from an Avio 550 and decided to upgrade to a 560, it's the addition of this module. This technology is based on flow injection technology. It's been around for quite a while, and I'll discuss this in a bit and how it can improve your throughput. So if we look at a standard analysis of an ICP-OES without HTS, you'll see a lot of time of the analysis is getting the sample into the plasma and then stabilizing in the plasma and then rinsing the sample out. This time getting in and out is really a drain on sample turnaround time. So with flow injection technology, with the HTS system, we're able to really reduce all the time to get the sample in to the system and get the sample rinsed out. So you notice on step 3, the measurement step, that doesn't change. That stays the same. So the analytical portion of your method does not change at all. And it really, what it does is it reduces the amount of sample being used. So you consume less sample, a lot less sample goes into the sample introduction system, less sample goes into the plasma, keeping things cleaner longer as well. But ultimately getting your results faster. Okay, now I'll talk about the Avio 560 Max used with geochemical samples as in this application note here. And it's also should be in the handouts, or feel free to reach out or look on our website for this application note. So with geochemical samples, of course, we know some elements may be present at very high concentrations, which requires long washouts. The beauty of having the high throughput system with the Avio 560 Max is that you're going to get faster sample time and increase your productivity, but also it ensures better washout. It's a great benefit of the system. Also reduces waste, so reducing your environmental burden. So the samples in this application note were stream sediment reference materials from the China National Geophysical Institute, as shown here. I'm not going to go through all the concentrations. You'll see there's a variety of sample types with a range of concentrations across these sediments. Sample preparation is fairly simple procedure. In this procedure, using a ½ gram of sample digested in a PFA digestion vessel with hydrochloric, nitric, hydrofluoric, and perchloric acid. We heat this sample with these acids at 180 C for 2 hours. Then the temperature is ramped up to 240 C until we get to near dryness. Then the vessels are allowed to cool, and we add deionized water to 50 milliliter final volume. And that's used for analysis. All calibration standards were made in 2% nitric. It is an external calibration, not method of standard addition or anything. And we had, near expected concentrations. We had made the concentrations of these calibration standards in the kind of expected range for better accuracy. The internal standard used in this experiment was scandium. Inter-element correction factors were used due to interferences from iron, aluminum, and titanium, which are some of the major components in these samples, and they were applied to beryllium, cobalt, molybdenum, nickel, and lead. As for the instrumental conditions, the instrument was operated with a glass cyclonic spray chamber and a Meinhard Type K nebulizer. Sample uptake rate was about 1 ml per minute, and only an 8-second read delay to get the sample in there. The loop volume was only about 1 ml, so we're using only about a little over 2 mils of sample to fill that loop, and it was then subsequently rinsed while being analyzed, or the probe was being rinsed while it was being analyzed, and then at the end of the analysis, the loop is then rinsed with some carrier solution prior to sampling with the next sample, or filling with the next sample. These are all the elements that were determined. So we have a listing of all the elements, the wavelengths, and plasma view for acquisition. You'll note that scandium was determined in both radial and axial modes, and this allows us to monitor the internal standard both radially and axially, and we typically will apply the scandium radial internal standard values to our radially viewed analytes, and we'll apply the scandium axially viewed intensities to our axially viewed analytes. Some of the nice features in Syngistix Smart software is the data viewer allow you to easily look at your results in both calibration units, i.e. the units in which you calibrated the system, and sample units. This is factored up results based on any preparation information you inputted into the system, like weights and final volumes. So it can do unit conversions for you if you want. And you can easily check out all your calibration curves and print out results or export results simply with one button click, the export all there. Another nice feature in the data viewer is the internal standards plot. I use this plot quite a bit just to glance at the computer from a distance and make sure the run is progressing without any issues. You can easily see if there's anything strange going on, if your internal standard starts drifting in any way. And for this particular analysis, it was pretty solid. The detection limits in this case were 3 times the standard deviation of 10 measurements of the calibration blank, then multiplied by 100 to account for the sample preparation factor. So therefore, this would be the instrumental detection limit in the solids. Then one of the things we want to look at is memory effects or washout in the system. How this was accomplished was by running a high concentration of standard containing, similar to what the samples would contain, high aluminum, iron, calcium, magnesium, potassium, and sodium, so high majors, in a run into the system for us to evaluate what the carryover is. So we saw very excellent washout, so basically almost 0% carryover on the system. And that's the kind of beauty of a flow injection system such as the high throughput system. So this bar graph is the compilation of all the results for recoveries for these 5 different reference materials that were prepared. So if you look, each bar indicates one of the reference materials, and it's listed by analyte. You can see that all recoveries are within the 10% error bars that are indicated by these solid lines. Stability. Of course, controlling for and monitoring instrument stability over the duration of your analytical run is very important. To achieve this, a CCV, or continuing calibration verification standard, was run every 10 samples. For most of the elements, the concentration of them were 0.4 ppm, except for the majors, aluminum, calcium, iron, potassium, magnesium, and sodium. Those were run at 100 parts per million. As you see here, it's a very stable run. If you looked at, you saw the internal standard as well. Everything looked very stable for this particular analysis. And we just kept on running the system for 8 hours, really to represent a full shift of work. Again, this is that reference material, one of the reference materials to demonstrate the stability of the system. It was analyzed 6 times during the 8-hour analytical run. And everything's within like a 10% spread. So in conclusion, this application note on the high throughput analysis of geochemical samples with the Avio 560 ICP-OES shows that the Avio 560 can easily analyze geochemical samples. There is no loss of data quality, actually maybe improved data quality due to the better washout and rinse out characteristics provided by HTS. So we get improved speed and improved washout. We're taking advantage both of the axial and radial plasma viewing on the Avio ICP-OES, as well the vertical torch, dual viewing, high throughput. The whole combination really provides a robust and cost-effective way to analyze geochemical samples. I just want to acknowledge one of our application scientists who did this work, Julie Cheng, in our Shanghai office. To download the application note, I do believe I have a download link in this webinar, If not, you can always visit www.perkinelmer.com/Avio560max. Well, thank you for taking the time and signing up to listen to my talk on geochemical analysis. I should have some time now to take any questions. If you have any further questions that pop up, please feel free to email me at any time. All right, thanks. All right. I guess now, yeah, we can take some questions. Remind everybody that for questions, they can be typed into the panel on the web-based here or in the application here. Bella, are you available?
Yes, I am, and it looks like we already have a few questions coming in.
Okay, great.
So first of all, could this type of sampling work with a connected exhaust for a 7000 dV?
This type of sampling. I see what you're trying to say. Well, the auto sampler can work on a 7000 dV. The HTS isn't available for the 7000 model, but there are other options. Other vendors that do have flow injection valves that could be adapted to the 7000, like ESI or other vendors as well, like Teledyne.
Okay.
Yeah, if feel free to reach out for your specific model or configuration. I can help you out.
Okay, thank you. And then another question is, can I achieve a similar performance with an Avio 550 Max equipped with a fast valve system?
Yes. Yeah. It's any flow injection is pretty much similar. I mean, there are some differences from system to system, but yeah, you're going to achieve same sort of gains with the fast system.
Okay, thank you. And then for this work, what was the sample to sample time?
The sample to sample time in this it was under 60 seconds. I think it ended up being something like 55 seconds or something like that from sample to sample.
Okay, thank you. And what was the model of hot block that you recommend?
So the hot block used in this work was actually the PerkinElmer SBP50. I believe she was using the 24 position model, but we have a couple different models with different tube size and vessel, like digestion vessels you can use, as well as the number of positions in the hot block. So this one was a 24 position, but there is also a 48 position model for the 50 milliliter vessels.
Okay. And can cesium be quantitated with the Avio?
With our Avio, you can quantitate cesium on certain wavelengths, yes.
Perfect. Does the one-piece pump require any maintenance, or is it a plug-and-play design that is entirely replaced when necessary?
Oh, so the peristaltic pump is there. There's also a vacuum pump there. The vacuum pump usually it's rinsing itself out between samples, so it's not really maintained necessarily. It either works or it doesn't. So it is able to be uninstalled and swapped out fairly easily. What does require maintenance on any flow injection system with a valve is that the valve itself. So the valve does typically, on any system, need to be maintained and checked and verified that there's no, scoring on the interface between the stator and the rotor on the valves. Any valve system you'll want to do regular maintenance and review to make sure it's flowing properly.
Okay. And have you tested the B carryover?
Boron. Yeah. I mean, there's a lot of work people do on boron. Yeah, it can be a pain because it is a soft cation. It doesn't really like to wash out very well at very high concentrations of boron, of course. So the nice thing with this flow path being smaller and rinsed out much more efficiently is that it reduces significantly versus not having flow injection at all. So yeah, there's definitely going to be improvement there. And remember, we're not loading the spray chamber with like a fast pump. The other issue I kind of didn't talk about is if you're fast pumping the system, you're actually overloading typically the nebulizer, spray chamber plasma with liquid, and that actually exasperates a lot of carryover condition. So by keeping a constant carrier flow rate into the nebulizer and ultimately for the aerosol generation into the plasma, helps reduce carryover effects actually as well.
Okay, this question's a little bit longer. Is there any information on running samples with different digestion techniques? For example, would the high matrix effects of fusion digestion or the residual high frequency from a microwave digestion without drying affect the way this method is employed?
Yeah, yeah, of course, yes. The simple question is yes, of course, it would affect how the method is set up. So the long answer, I can dig into that. So we'd have different application notes on different digestion or preparation methods. So for fusion digestions, as you know, there's a lot more solids typically in a fusion digestion. They're complete digestions typically as well. So there's a lot more material. So typically there are different plasma conditions for fusion digestions for sure. So that would be tweaked typically slightly for fusions, although this digestion is a complete digestion as well. So you still have quite a bit of TDS going in there. But yeah, there's definitely consideration for fusion, depending on what type of fusion as well. Sometimes if you're running a lot of fusion samples, a lot of salt, a lot of sodium potentially, sometimes I even use silicon nitride torches, like zip torch or D-torch systems to reduce the amount of cleaning and maintenance you need when running fusion. And then for residual HF, yes, that would change as well, depending on how much HF or hydrofluoric acid you're using. You could run it. It again depends on your safety as well in your laboratory. You could run it on a system, but if you have significant amounts of HF, you would typically want to go to an inert sample introduction system. So you'd go into like our cross flow Riton spray chamber system. So this was the work was done with a glass nebulizer and spray chamber, but you could go to a Riton spray chamber with a cross-flow nebulizer or another plastic or polymer-based nebulizer, so you don't have HF wearing at your nebulizer or chamber. That's usually what I'll do if there's HF above 1% in my samples.
Okay, thank you. Very thorough answer. We have a little bit more of a simple question. What is AS range pump speed?
The auto sampler rinse pump. Okay. So the auto sampler rinse pump speed. It's just faster. I forget what it is off the top of my head, a default, but it is variable. You vary it based on the amount that you need, basically to keep the rinse station filled during the rinsing events. So I guess it's variable. I forget what it is off the top of my head to fill.
Okay. Would this technique work for testing for trace analytes like uranium or lead in solutions containing weight % sodium or calcium salts?
Okay, that's another longer one, but where is it? 8%. Didn't see this. Can you repeat that one again?
Yeah. Would this technique work for testing for trace analytes like uranium or lead in a solution containing weight % sodium or calcium salts?
It really, well, I mean, yeah. So trace, I mean, depends what talking about trace. But it could. Uranium and lead aren't the best by optical emission. Typically, a lot of that is done by ICP mass spec. Again, it depends on the concentration, but a lot of that I see mostly done by ICP mass spec when you're talking trace, especially trace uranium.
Okay. And what would be a reason that the Y peak looks different or less pointy between an Optima 7300 to Avio 550 max for element Y internal standard?
I mean, that's kind of just how it draws it in the software, but yeah, it's just how light is projected on any spectrometer could vary by a couple picometers from spectrometer to spectrometer. So how it represents itself in a pixel to pixel drawing can vary a little bit.
Okay. And that is the last of the questions. If there are any other questions, please type them in the chat. But thank you, Aaron.
Yeah, no problem. Well, again, if anyone wanted to download handouts, they are there. There's a few. And again, thank everybody for today's webinar, for joining today's webinar. To locate all webinars in this series, feel free to go to atomicwebinars.com and you can peruse the different sections. Again, thanks to everyone for joining today's webinar. If you have any other questions, feel free to reach out to me. Once you leave today's webinar, you'll receive a survey on the presentation. I'd appreciate if you can complete that, provide any feedback, any suggestions for future topics even. You'll receive a follow-up email in about 24 hours with a link to the recording of today's webinar and a certificate of attendance. So on behalf of PerkinElmer, and I'd like to thank you again and have a great rest of your day. Bye.